Welcome to the video notes for lesson 10-8, graphing piecewise functions. I know that it says 11-8 at the top, but it's 10-8. That's a typo, and we're on page 45 in your notes packet. Alright, the lesson targets. I can graph piecewise functions, and we'll talk about what piecewise is. And I can identify increasing and decreasing intervals of piecewise functions. So, list the series of events for the piecewise function. Piecewise means we have a little bit of one function, a little bit of another, attached to a little bit of another. It is not all linear, it is not all quadratic, it is not all exponential. I think you can tell when you look at this graph that there are some parts that are linear and some parts that look like they might be exponential or even partly quadratic. So, which is kind of what happens in the real world. Not everything is all just one function of something. There are some type parts or pieces, if you will, that interchange. When we're looking at this example here, I think of this in 4 different sections. So we have this first section here. It's kind of a flat section. Actually, it's got a little bit of a wobble here, but this is and this is like just a constant attention span. It is linear. Then we've got this section here that's increasing. So when a teacher yells for attention, it gets the attention of the students increases, and it looks linear. Then as the teacher starts talking, well, you know how students are, they start to drift a little bit. Then we have this section here, C, which looks either as part of a quadratic or even exponential, but it's decreasing. Decreasing, that's the key. So A is a constant interval, neither increasing or decreasing. B is an increasing. And then C is decreasing, and they are different functions, clearly. And we even actually have one more at the very end, this where it just drops right off. You might say that there is no attention, no function. It might seem as though it's decreasing, but there's really nothing happening there. So, all right. So that's page 45. It's just kind of a general example of what piecewise is. All right. So on page 46, we are going to describe the intervals of the piecewise graph. So the first interval that I see is from here to here, and I'll call this A, and this looks linear, and it is decreasing. So going from left to right, what's happening? It's going down, so decreasing. And it's from the interval, so if I count over, it's -7, and it lands on -7, so it's going to be a square bracket, to -4. Now I'm going to use a parenthesis for this and say, now I know that it's shaded in circle here, but I'm not going to include -4 with this point. And notice I'm doing just the domain here and not the range, going from -7 to -4. Now, The next part, B, that's right here, it looks like it's increasing. It's linear also. This time, I'm going to include the -4 with this. So, this is the part you have to understand. If I had put a square bracket up here for -4, and you could have, then down here we would have to put a parentheses, because it can't be a part of both of them, at least not for this situation. So, it is included for this next section, part B. And then, again, when we get to -3, I'll use a parenthesis here, because I'll let the next part be included with C. Change my color here. Now I'm going from -3 to 0. It is still linear, but this time we're going to call it constant. It's not increasing or decreasing. And we'll include the -3 with this one, but not 0. So going from left to right, notice I include the first one, but not the second one. Again, it's not wrong if you did do a square bracket for, say, the first section, but then you would not want to do that for the following one, because if it's included with the first one, it can't be included with the second. All right, so our next section looks a little different. So this we'll call D, and I changed my color again. And this time we have a quadratic. And for section D, quadratic, this one is decreasing. Now I know you might be saying, well, doesn't a quadratic decrease and then increase? Yes, it does. But with this one being below the x-axis, we're going to say it's a decreasing. Oops. Arrow notation. And we'll go from, it looks like we're going to go from 0 actually to 1. And that's why it's decreasing, because we're going to include from 1 to the next part, which is also quadratic, so E. But now it's going from here all the way up, so we'll call that the increasing interval. So going from, square bracket, 1, we're going to stop at 5, up here at the top, at the vertex. Now, going from here down to this point here, it's still quadratic, so section F is quadratic. But again, so it's decreasing because it's going down. Interval is from 5, so I'll square bracket because I didn't include it with the other one, to 8. And then the last one, now I know you won't be able to see the graph on my screen anymore, but G, hopefully you can tell, is back to linear. It is going to be increasing. And so since I didn't include 8 with the last one, I'll include it with this one. And I also will include the last point, which has a domain or x value of 12. Alright, so this is how you are going to describe the intervals of a piecewise graph. Essentially by doing the interval notation for the domains. Alright, over on the next page, we have a real simple little task. I actually kind of like these. I know it sounds weird to some of you. Graphing the piecewise function. So, what you're going to do is, you'll plug these into your calculator one at a time, and then you're going to just use the points that you have. So let me see if I can pull my calculator up quick. You'll use the points just for the intervals that they state. So the first one is going to be y equals 1/2. So I'll do, well, I can do 1/2 raised to the x. And then I'll go to graph. And when I look at my table, I want the table from -3 to 0. So these are the values, and let me pull that over here because you can't see it. From -3 to 0, so -3, 8, -2, 4, -1, 2, 0, 1. So let me pull my, there we go. So for this first one, I'll make a table, and this is for the function f of x equals 1/2 x. So my x values are -3, -2, -1, 0, not -0. I've got 8, 4, 2, 1, I believe. Let me just double check. Yep. And then you're going to plot those points. So now you also have to keep in mind that we're going to be using our inequalities here to help us decide what to do with those points. So the first one, -3, 8, is shaded in because it's less than or equal to. Then I have -2, 4. Then I have -1, 2. And then I have 0, 1. Now 0, 1 is not, it's just greater than, so I've got to have an open. So then I connect it, and I'm done. Now sometimes your piecewise will be connected, sometimes it won't. So next one is going to be x to the second power. I know this one doesn't look very clear, so this is going to be a quadratic going from 0 to 3. Notice that when it's 0, so 0 to the second power is just 0. So this one is actually going to start below here. It's going to be a shaded in circle. And so you want to do the table for this one as well. And it's going to go from 0 up to 3. 1, 2, 3. And then for the linear, you're going to do from 3 to 7. 3. Oh. Yeah, 3, 4, 5, 6, 7. I'm going to let you finish this on your own, but you should remember how to do this kind of graphing. You only need the points and values that they give you in here, and just make sure, so when it's less than or equal to, you shade it in. The end point for this quadratic is not going to be shaded in, so you'll have an open circle somewhere up here. Well, when it's 3, it's going to be 9, so it's going to be right here. But you've got some points in between. So you connect this with the half parabola. And then, when you get to this one, it's actually going to be starting back down here and doing a linear with an increasing interval. All right? Okay, so that's it for this. On the next couple of pages, you've got some great practice. Page 47 or excuse me, 48 has the answers at the bottom to help you if you need it. If you had any trouble, go back and rewatch the video or come and see me for help. Good luck, and we'll see you in math.